Can a tiny machine learning model predict the winner of an NFL game? I built one in under an hour, and here's the exact pipeline I used, so let's break it down. Tomorrow, the Steelers play the Ravens in Pittsburgh, and my goal here is simple. I want to build a machine learning model that looks at what we know before kickoff in past games, learns patterns from that, and outputs a probability that one team wins. First, I need historical NFL game data, so I'm grabbing this one from Kaggle. At a minimum, for every game, I need the date, the home team, the away team, and who actually won so I can label each game as a win or loss. And for my target label, I'm going to keep it clean and simple. If the home team wins, it's a 1, and if the away team wins, it's a 0. That turns the entire problem into a standard binary classification problem, which is exactly what beginner-friendly machine learning models are good at. And here comes the most important part, but also the part that most people mess up on, and that is feature engineering without cheating. I obviously cannot use any information from the game I'm currently trying to predict because that would be data leakage. In a real-life scenario, you don't know anything about the game that's about to be played except for the teams that are playing. So I'm creating features using only information that would be available before kickoff. For example, I compute each team's win rate over the last 5 games, a rolling point differential trend, how many days of rest a team had since their last game, and a simple home field indicator. And to make it even stronger, I can add a team strength rating like ELO. The key here is that every single feature must be something I would have known before the game started. Once the features are ready, I split the data the right way. I'm not just randomly shuffling the NFL games like they're independent because time matters. Teams change, coaches change, injuries can happen, and the league evolves. So instead I'm doing a time-based split. I train on earlier seasons and test on later ones. That simulates a real-world simulation where you're always trying to predict the future using the past. For the model, I'm starting with logistic regression. This is a method that looks at all of the available inputs and decides how important they are when it comes to predicting whether the home team will win. Each input's importance is assigned to it with a weight. The model keeps continuously adjusting these weights over and over again until the loss of the function is as low as possible. When all is said and done and we've substituted all the given inputs, the model gets a single score. Then it uses the sigmoid function to squish the score into a probability between 0 and 1. So when I build this, I'm not just asking who will win, I'm also asking how confident should we be. A prediction like 52% is basically a coin flip, but a prediction like 70% is a much stronger lean. So I train the model on my training set and then finally generate the predicted probabilities based on my test set. Now it's time to evaluate the model, but not just with accuracy, because it can be extremely misleading, especially when it comes to sports. Instead, I'm looking at logistic loss or log loss to capture whether these probabilities are meaningful. And then I check the calibration, which tells me if the games the model calls with 70% certainty actually win around 70% of the time. Of course, if the model is overconfident, then the accuracy might look amazing, but the probability estimates might not be so good. And for decision-making, probability quality is the whole point, so here are the evaluation metrics for this model. Now we can actually deploy the model to work for a real-world scenario. So I take the upcoming matchup between the Steelers and the Ravens, compute the same pregame features for both teams, feed that row into the model, and watch it output a probability. And the model predicts that the winner will be the Steelers, but only with 55% certainty. So this is an extremely tight game and could honestly go either way. So that's the full pipeline. Get your historical data, generate your pregame features without any leakage, train the model, then evaluate the model, and finally use it on a real-world matchup. So don't forget to save this video so you can come back to it after the game tomorrow. Let me know who you're rooting for in the comments and follow for more. See you in the next one.